So now in front of you, the second one more type of eccentric loading problem. In this you can see in front of you there is a steel plate and which is fixed by 3 bolts. The load of 5 kilonewton is applied at a distance of 200 from that structure. So this is the problem in which the load axis and the screw axis they are not in plane. A steel plate subjected to force of 5 kilonewton and fixed to the channel by means of 3 identical bolts. So 1, 2, 3 are the 3 bolts. The bolts are made from plain carbon steel having permissible shear stress of 63 megapascal. Specify the size of bolt. So here we have to specify the bolt size. Okay. So the same figure I have drawn here on our board also. Now in front of you there is a 3 bolts, 1, 2 and 3. Okay. These three bolts these 3 bolts are fixed in that particular structure and which is going to support our bracket. Now because of this 5 kilonewton load which is coming down, there is a direct shearing of this 3 bolts and there is a turning also because of the moment. Now number one, the first is the direct shear load. Okay, so this direct shear load ws1 that we can find by very simple way, whatever total load divided by number of screw. So here total load is 5 kilonewton divided by number of bolts are 3. So direct shear load that comes out is 1666.67 newtons. The second load is a turning load. Because of the turning, as we can see, there are 3 bolts, and three bolts are having symmetry about this plane. This is the point about which there is a symmetry. So this is the point. The center point of the bolt 2 is the uh, CG of the complete plate, and it is going to turn about this point. So whenever there is a turning, the second bolt will act as a center of turning, and this 75 distance are act as a radius for turning. So that's why here second type of load is the load because of the moment load. The moment load is also shear load, the moment shear load. So that is the second load. So here there is no any moment about 2. So the load on first and 3 is important. On second the moment is 0. For the second the moment is 0. Only we are interested in 1 and 3. So let us go for second shear load, ws2. So ws2 that we can find here equals to, I'll put that ws2 here so that we can proceed. So that ws2 equals to whatever moment W into L, multiply by whatever distance for this first or third. So I'll say W, so that is L1 divided by, okay, divided by whatever radiuses. Here only two radius is there, L1 square and L3 square, because for L2 the radius is 0 or there is no turning. So this is the equation. There is a turning radius about this, so it is only for L1 and L3. Okay, so I'll put that load and everything. So there is a 5000 as a load, multiply by. Now when we think about this moment, moment is equal to 200 plus 30 plus 75, so it becomes 305. So it is 305 from the center of rotation, because here this is the center of rotation. So from the center of rotation, how much is the distance? So it is going to rotate like this. So a complete rotation is about this center. So 5 kilonewton multiply by this much distance is the L, multiply by how much is the radius for this first or third. So it is 75. It is 75 because the distance here from the center of rotation is 75, divided by, now L1 and L3 both are having 75 distance. So 75 square. So second shear load that comes with this is 10166.67 newtons. Now the total complete equivalent load on this is whatever direct shear load plus whatever second load. Okay, so here the complete total W is equal to, now we have 1666.67 plus 10166.67. So this is the complete load. So it comes it just, if I find this, so it becomes 11833.34. This much Newton is the equivalent. Now we have here shear stress 63 megapascal. 63 megapascal is the shear stress. So that shear stress equal to force divided by area. So I'll put here shear stress equals to whatever force divided by area. Okay, so 63 equals to 11833.34 divided by pi by 4 dc square. Okay, pi by 4 dc square. So from this the dc, the core diameter which will come out is 15.42 mm. 15.42 mm. So we can take it as a 16 mm, and this is the same screw diameter we can bolt diameter that we can take for first, second, and third. We can find nominal diameter by using our simple equation like this. So if I want to find the nominal diameter, so d0 dc divided by 0.84, this is core diameter. So we can put that, and we can get nominal diameter as something 20 mm. So by this way we can find the second type of or third type of eccentric loading problem, in which the load axis is not in plane with the bolt axis. There may be chances that there are, instead of 3 bolts, there may be 4 bolts, 6 bolts. So we have to consider the whatever radius or whatever L1, L2, L3 distance from the center of rotation of that complete plate. So we have to find the CG about which the plate is going to rotate, and from that we have to take the distance, all the distance, to get the second type of shear stress. So this completes our the problem in which we find the size of bolt.